according to Max. Book 14, Silver Penny. Amy Wang.
It started with a missing coin. Max rushed in from school, dropping his backpack by the door, already looking for it.
Mom, have you seen my silver penny? I need it for the science club.
The shiny one from your old experiment? I remember it.
Amy smiled. The first clue came years earlier, when 8-year-old Max discovered a scratched penny. The copper layer wore away. Underneath, a dull gray metal. The zinc beneath reacting with air and turning into a grayish zinc oxide.
Wait, why isn't it copper inside? Did someone fake this penny?
Amy pointed to Max's coin bank. Time to investigate.
I don't know. Let's figure it out.
They gathered pennies from different years. Old ones, new ones. They spread them across the table and searched online. Max leaned closer. Pattern was appearing.
These look different.
Older pennies are heavier, and when new, they were solid copper.
Pennies used to be almost all copper.
Amy pulled up a chart. What they were about to discover wasn't a science problem. It was an economics problem.
In the late 1970s, copper became expensive. The price kept rising. By 1980, the copper inside a penny was worth nearly as much as the penny itself.
Amy paused. The mint had a decision to make.
If the metal costs as much as the coin, then making pennies loses money.
Exactly. So in 1982, the mint changed the design. Copper on the outside, zinc on the inside.
Max studied the diagram.
Why zinc?
It's much cheaper. And it still works for making coins.
Amy drew a simple cross-section. A thin copper shell on the outside. A zinc core on the inside.
Copper is tough on the outside. It doesn't rust easily. Zinc is lighter and way cheaper, but it doesn't like getting wet or scratched.
So if the copper part chips off, the zinc underneath just falls apart?
Exactly. That's why the outside coating matters so much.
So you could put a different coating on top? Like a silver one?
Amy smiled. That was exactly the right question.
With chemistry, yes.
Yes, now I remember. Can we replicate the experiment?
Sure.
Max laid everything out on the table. Every experiment starts with the right materials. A penny. 2 identical nickel strips. A and B. Wires. Alligator clips. Batteries. Solution or salt, vinegar, and water to make your own.
Before we start, we need all the right pieces.
Good science starts with preparation.
Max pointed to the first nickel strip A.
Strip A is connected to the positive terminal. This side is called the anode.
The strip A, nickel atoms began losing electrons. In equation form, nickel becomes nickel 2 plus 2 electrons.
That process is called oxidation.
The released electrons could not travel through the liquid, so they moved through the external circuit instead.
The electrons leave strip A, flow through the red wire, enter the battery at the positive terminal, move through the battery, then come out from the negative terminal into the black wire.
The electrons continued traveling towards strip B. But inside the liquid, something else was moving too.
When nickel atoms leave strip A, they enter the solution as positively charged nickel ions. Nickel 2 plus.
These nickel ions drifted through the green solution towards strip B, the negative side.
So the electrons travel through the wires, but the nickel ions travel through the solution.
2 different flows were happening at the same time, electrons through the circuit and ions through the electrolyte. The 2 strips were now doing opposite jobs.
At strip A, oxidation occurs because nickel atoms lose electrons.
At strip B, reduction occurs because nickel ions gain electrons. In equation form, nickel 2 plus 2 electrons becomes nickel metal.
As nickel ions grabbed electrons at strip B, they turned back into solid nickel metal. Strip A slowly became thinner, while strip B slowly became thicker.
What if we replace strip B with a penny?
The penny was connected to the negative terminal, so it became the new cathode.
The nickel ions still move through the solution toward the negative side.
When the ions reached the penny's surface, they grabbed electrons and changed back into nickel metal.
Now the nickel forms directly on the penny instead of on strip B.
A thin silver-colored nickel coating slowly spread across the penny's surface. atom by atom, layer by layer. The copper-colored penny slowly transformed into a shiny silver penny.
That's electroplating.
The nickel coating is thin, but it completely changes the surface.
Inside, the penny was still mostly zinc with a thin copper layer. But outside, it now carried a brand new layer of nickel metal.
We're not creating metal, we're moving it from one side to the other.
Max drew a quick diagram to show what's really inside.
Nickel on the outside, original copper cladding underneath, and zinc in the core.
Every layer has a story.
It started as mostly copper, then copper outside, zinc inside, now a thin silver-colored nickel layer on the outside. Every change had a reason. One was economics, one was chemistry. But the penny kept going.